Welcome again to my YouTube channel. If this is your first time, please consider subscribing and liking the video. If it helped you, feel free to just give a thumbs up, or even just like it. If you have any question, just put it in the description. Then I can answer your question, or even I can reach out. Thank you. So today we are looking at the question: find minimum in a sorted in a rotated sorted array. Yes. So this is a read code 153, and yeah. So the question goes: suppose an array of length n sorted in ascending order is rotated between 1 or n times. So it means the array is going to be, it can be rotated 1 or n times, so it can't go above the number of elements in the array. Then, for example, the array, this 0 1 2 3 4 5 5 6 7 sorry, 3 is not there, can be rotated, for example, here, if it was rotated 4 times. So to know it, for one to be rotated, as you can see here, the last number comes at the front, so that means it's rotated. So for example, here, to know that it was rotated 4 times, you can see we started with this, then 7, we bring 7 on the front. That's the first time. We bring 6 at the front, so 6 goes in front of 7. That's the second time. We bring 5 in front of 6. That's the third time. And then we bring 4 in front of 5, which will be the fourth time. And this resulting in this array, which they tell us it was rotated 4 times. Same thing happens here. So you can see when you rotate n times, it goes back to the original array. So notice that rotating the array works like this. So this is what I was talking about. And then they tell us, given the sorted rotated array of unique elements, return the minimum element of this array. So, and you must write the algorithm in O of log of n. So most of the times, for example, you might give something like return minimum element, that will pass through all elements and then find, you can use a linear approach where you just go through all of the elements, and then once you find the minimum, you return it, which return in O of n, not O of log n. And whenever they tell you to look at O of log of n, whenever you see something that you have to return O of log of n, it means you have to provide you have to use a binary search. Yes, so looking at the example inputs, you can see we have 3, 4, 5, 1, and 2, and this is the minimum. How do we get to the minimum? Like I mentioned, we need to use the binary search algorithm. So we initialize a left and the right pointer and the middle pointer. So what we do is we will check between these two, which one is smaller. So for example, is this smaller than this one? Yes, it's smaller than this one. Now, since it's smaller, is this one smaller or greater than this one? Because if, for example, it was rotated once, then you see this might be bigger, but still you will find that the middle element is on this side if it was rotated once. But now, yes, so if it's this one is, so for example, this one is bigger than this, but this one is less than this one, so this is the subarray. We put our left pointer here, and then we stay our right pointer here. We calculate again the middle element, which will be here, and then this one is less. The middle element is the the left pointer value is less than the right pointer value, and the right pointer value is greater than the middle element, which means we have to shift our right pointer, and the right and left pointer are on the same position, and they show on one, which is the minimum. So as you can see, every time we get the pointers pointing at the same time, at the same position, that's when we have the minimum element. Something would apply here, and all of this. For example, here you can see our left pointer here, our right pointer here, and the middle pointer here. Now the left item is greater than the right item, and the right item is less than the middle element, which means this is our new subarray to check from. We shift our left pointer here to 0, so our left pointer goes from 0 to 0, and the right pointer is still here, and then we say the middle element will be 1. So we now again check, but this time the left pointer is less than the right pointer. The left pointer is less than the right pointer, and then yes, there is less than the right pointer. So it means we have to move this, and again the right pointer is greater than the middle element, so we have to shift it to P4 to O2. We have to shift it, and now they're pointing to 0. All of them are pointing to 0. Same case goes for any thing. So if you look at the solution now, apologies, let me show you. Let me try to reduce the size so we can see. You can see I have this value which will hold my minimum element, and then I have the left pointer which is at the start, and the right pointer which is at the end of the array, pointing at the end of the array. Now for all the time when the right pointer is less than or equal to the left pointer is less than or equal to the right pointer, it means I don't want them to switch like this. I just want they can be together, or they can be approaching each other, but there should not be a time when they close. Then if our left pointer is equal to the right pointer, then the minimum element, we have found our minimum element, and there is no need to continue the loop, so we break. Otherwise, we do what I was describing. We say, is the minimum element greater than, or is it greater than the right element, which is this? Comparing these two, yes, it is greater than. So, but is the right element greater than the? Is it greater than the middle element, which in this case it is not. So we have to shift the left pointer, shift it here, so that we can move, or so that we can show our so that we can go to a new subarray to check from. So if it was greater than, then we should shift it to this place. Then we say this is the moment when the left is less than the right value. So that time, if this is the case, we check if the left is greater than the middle element, which is to say, okay, is it still greater than? If it is greater than, we still need to shift our left item to the middle element, because it means it might be rotated sometime, but we still need to have we still find that it is in the subarray after the middle element. Same thing happens if we don't, for example, if nums is less than, if the left element is less than the middle element, then we shift our right pointer so that it comes to the subarray where we can find the minimum element, and at the end we just return the minimum element. If you want, you can just return here, but yeah, it depends. then if you run our solution, works. And also if you submit, yay, we beat 100%. And okay, yeah, thank you.